This one, we do have some issues. We believe there's going to be a coil driver. So we've had a look already on the fault codes. Now, yep, it is in German, but you pick it up fairly quick. So we have coil 1 seen 6 times, coil 2, coil 3, coil 4, coil 5. That's tank ventilation valve, injector cylinder 5, lambda regulation, throttle potentiometer. Throttle potentiometer, that's because that's not going to be plugged in at the moment. It's not powered up. Relay secondary air pump, relay electric fan, and active. That's the oil level sensor. So what we're going to have to do now is have a look, and we'll open that up and we'll check and see how we get on with the drivers. Right, that's the lid off. You will see this is how they you get them on the inside now. These metal clamps are to hold our various chips back against the case. It's an aluminium, or it may even be there might be some magnesium in there, but that's going to be used as a heat sink for a lot of these chips. Our ignition coil drivers are over here. I can already get a smell, so I know, yeah, there is likely going to be something gone, and I can see something just there, which I think is going to be some melted plastic. So doesn't look as bad as some of the ones I've seen before, but this one I think we're going to find something. So I have to prise these up first, if I can get in. There we go. That's our metal clamp off. And now this guy. There we go, he's out the way. So yeah, I see melting there. That's between these two guys. So we'll have a closer look now at them two and see what has gone on. There's a closer look zoomed in, and you should be able to see that. I'll just get around here. But yeah, this corner here, we've got a big crack running over there. So this guy most likely is going to be dead, but I will check these other ones just to see sort of what's going on with them as well. Make sure they're all right. If it's here, it only takes a minute to check, so best to get that done rather than sending it out and saying like, oh look, there's another misfire here and another cylinder, and then me realizing then, you know, I could have had it all sorted at the same time. Okay, I've got my multimeter in the back so you can see it. So as I say, we're on the diode check, and if we go across these two coils, 1.20, 1.21, 1.20, 1.21, this is our bad guy, 1.20. That looks good, and that would be kind of passing the test there. And this one, get my hand out the way, 1.21. Now if we go on the other leg, so this is our common ground, which is just to the chassis. Power comes in on the middle, and there's our trigger. We go between these two. Nothing, 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 nothing. This guy, look at that, 0.81. So that is passing through a diode when it shouldn't do. So I believe that one of the diodes in there might have gone. You have in a MOSFET, it's to cover more power, you will have more than one transistor, and each time you go through a transistor, they appear as a diode to they act very similar to a diode. You will see a voltage drop of about 0.6 volts to 0.8 volts through most of the dies. There are some even sort of lower drop ones. So the 1.2 we're seeing is going through 2 diodes. So on this particular one, it hasn't shorted. There is our oh, there we go. In fact, we get oh yeah, we do show some stuff. They're different. Just realised my hands are blocking a lot what you can see there for that guy. So the 1.2 between our trigger and our output through the 2 diodes, but we have a diode drop between our input power and our trigger when they should be isolated like these guys. So what we'll do is we'll get this guy out and exchange him, and then what I'll do, we'll do another little check afterwards just to show you again what it's like. So we're inside now. One of the things I always like to look at is this plastic sheet. This is just for insulation, just in case anything bangs the case, because you don't want the aluminium shorting on anything hanging around here. But it can give you a good clue if anything else has gone wrong, as if there is something burnt, you will see a little black sooty mark on here somewhere. You can then check and see where it is, and that can narrow you down to stuff that's obviously melted, burnt or whatever. But this one here, it all looks good. I have put a little X just here by the one we're going to replace. It might sound like a silly idea, but when you are flipping these things forward and back, you can sort of very quickly sort of lose track of what you were doing. We were the second one in from the far side. Once we flipped it, that's not the one we want to get. We're now over here, and this is the guy. So we have 3 little legs to unsolder, and then we'll remove that guy. So first thing I do is take a little bit of flux on these. I first heat it up, at least give it a clue that we're about to be taking them out. That starts getting a bit of heat into our component, and then what we'll need to do is get these legs out. So 3 legs on these. The inner one was our power in. That's not the trace that we see. There is a little trace that we can see coming off there. That's not the main power trace. That is just for sensing. So it runs through sort of resistors here, so it doesn't get the full current going through. But one of these, obviously, as we mentioned, was the main ground. And that's the guy that's probably going to be one of the hardest ones to unsolder, because when it's on a ground plane, a lot of the heat wicks away into the rest of the board, and it can make things a little bit tricky trying to unsolder him. So I do these with a solder sucker. I'm going to heat him up there, and we can see he's loose. And then we're on to our next one. And this one. Okay, so we've removed most of the solder there. but there still could be little bits of it hanging on. This is where things can get a little bit tricky. If you haven't cleared all the solder, the last thing you want to do is start pulling on these hard, and you could end up tearing out the via. The via is the copper plated tube that runs through the board, and that sort of makes a lot of the connections. If there's slight traces of solder and these things don't come out just falling out by themselves, then don't pull them, because it might mean that some of the solder is still holding on there in the background. Right, I've given that another couple of pumps off camera. You can see these might have dropped down a little bit, but what you can do is just grab them and give them a little bit of a wiggle, and if you see it nice and loose, then you're clear on that leg. If we go to this one, he's still solid, so there's still a bit of solder holding that fella in. And this guy, this one, oh, he's free as well. Right, so we only have one left, which is this one, and then that guy will drop out. As predicted, the guy ejected himself. There he is there. If if you can catch the reflection, you can see the crack and the melt in that one. This one, it's probably highly unlikely that it's done any other damage to the board, unlike the one we've seen in a previous video where all of this section generally caught fire. This one, because he hadn't actually shorted the output part of it, the coil's going to be okay. I would often recommend, if you are replacing one of these, you'll probably want to replace the coil as well, as if these things go short circuit and leave the coil on continuously, the coil can then get scorching hot. That might be able to melt some of the wiring in the loom, especially where it runs through the tightly bunched up sections and all taped up. It can hold a lot of heat inside there, and you can end up with the wiring melting to other stuff and causing other problems. And also the coil, if the coil overheats, you could end up burning some of the internal insulation on that, and then next thing you know, you stick in a new driver, fire the whole thing up, and might fire a couple of times, and then next thing you'll have back to the same sort of thing where if the insulation breaks down, the coil might be able to then fire back your your secondary voltage, 40,000 volts back into the ECU, and then you're sort of back to square one. So quite often, yeah, you might need to do some extra checks on the wiring to your coil pack and the coil pack itself. This one, I would say, the way that it's gone, I'd say we're going to be all right with this. This is an M52. This is where I'm most likely going to come across them, and it's the same thing that we'll do in those as well. There are ignition coil drivers sitting at the back there. There's two of these missing, as they've already taken them out and gone into something else. This, God knows what's happened over here. Some sort of repair going on, going into these things. Whatever it is, by the looks of it, this thing didn't work. So this is just a dead board that came to me. Check it out, and you know, when you see things like this going on, whatever it was, I think I couldn't fault find it any further. There's likely other stuff that's knackered around somewhere. It was just a case of like, move on with these ones. The M52 ECUs, they're going to be a lot easier to find, and there's no point spending 4 or 5 hours trying to troubleshoot this thing when you can just grab a second-hand one. The chips on this one, they are a slightly different part number, so if you are trying to repair them and you do find some different part numbers, don't worry about that. This particular ECU, the MS41, this is the European one, 41.0. There's a 41.1. in the US cars and 41.2 in the US M3 3.2. These driver chips, they're all going to be the same. They might have a different manufacturer, but they are all suitable, as I've come across the same ECUs, MS41s, with the STP chip out of the Evo. We'll see that a little bit later on. And whatever these guys are, I don't recognize that logo off the top of my head, but the part numbers are there. So yeah, you can salvage them out of another MS41, and don't worry if the part number is different. If it comes out an MS41, it'll work in an MSS50 and vice versa. There's a little view through our holes. That one's gone perfect, so all the holes are nice and clear. Not often that happens, and to be honest, this is one where it's gone absolutely fantastically. Quite often it can be a bit more of a pain trying to get these out. It might take a little bit longer. Don't think that if you're doing this it'll go as easy as it's gone for me, as to be honest, even I'm surprised that one came out the way it did. And also something else to remember now as well is when these are being pushing back up against our insulation, they can quite often be stuck against there. So you might find that you might need to break them loose. If I go between these two, they're holding themselves on quite well. And if you do, by the way, if you do fully take these things out, remember there is this little plastic spacer that sits in the back. He slots in from the rear side, and he's got little legs up the side just to hold these guys apart. But yeah, if you are taking them out, quite often what I do is I'll just give it a little bit of a twist, and there we go, and that just breaks him free from the stickiness in the back. There is no glue on that. It is just the fact that it's been spent 15-20 years clamped solidly onto that electrical insulation, but sort of thermal conductor through to the case. Okay, we've got our new chip now. There he is. Now if I can move that so you can see, STP8055. Now I imagine a lot of people are going to be asking, where do you get these chips from? So if you Google that, you will generally just find a lot of people with similar ECUs doing the same sort of thing, saying like, hey, where do we get these driver chips from? They have something very similar gone wrong with them. The most common place that you will come across these is in the Siemens MS41 ECU. That is out of your E36 M52s, your early E39s and so on. And to be honest, that's where I get them from. I take them out of old ECUs, dead ones that have other issues, and I salvage the parts, and that way at least I know I have the exact correct part. There might be other suitable replacements. If you are aware, you can drop some info down in the comments and help people out, pass it along if you do know. But yeah, where I get them from, which probably is not a lot of help for an awful lot of you, is I salvage them out of other ECUs I've already got that are already dead. So this one's not too bad. Sometimes you might have a lot more solder still stuck on the legs. You want to make sure that he will fit into your hole. Come on. And by the way, like an idiot, I went to a spare ECU and I unsoldered one, and I unsoldered this one and I took him out. and that gave me a few minutes of confusion, as I couldn't find the chip that I just removed, because I'd seen this one on the desk. I thought, all right, that's our dead one. Where's the new one? When I looked, seen right, that one there. So yeah, in fact, I did in fact pick the wrong one there. So yeah, paying attention to what you're doing when you're working, always a good idea. Now we just got to solder him back in. So I have the chip put into its position. I put a little bit of Kapton tape to hold it there. Obviously when you turn this upside down, he's going to fall straight back out again. So to hold him in his right position, fully seated, I've got a little bit of Kapton tape just securing him. And now I'm going to put a little bit of extra flux. Flux is probably the key. If you've got bad solder joints, it might be just because they're not using flux. This isn't anything too fancy. Sorry, you can't even see this thing. There we go. Kingbo RMA 218 is this one. It's a kind of a flux. It's out of a syringe. Makes it sort of nice and easy to work with, and flux cord solder wire as well. So how you solder these things now, don't put solder onto the iron. What you'll do is you'll jab in at the side, so you heat both the pad and the leg at the same time, then feed your solder in from the other direction, and there we go. On to the next one. Get a bit of wire there ready, heat it up, give it a second, and we're in. I give it a fraction of a second longer for the heat to soak through and make sure it all gets into the right positions. Solder wire has an amazing surface tension to it, so that's why you will see these nice little sort of like volcano cones. And the last one, this is our tricky one, as that's our ground plane. Are we getting that? I can't quite see on the camera. There we go. Right, give that a bit of a clean up now, and we'll have a look and see how we've done. Okay, there he is now after I gave him a bit of a clean. If we can see there in the reflections, you can see we have a lovely joint on that one. So cleaned it up with a bit of isopropyl alcohol. That is why our little X that was there has now sort of disappeared. We have our nice little cones coming up onto the legs. If I flip him over, there is our Kapton tape that we can remove, and also check and see down here on the inside, and we have yeah, what we call kind of like the fillet. So we've fully come through onto this side. Going to give this a bit of a clean as well. That's smoke damage and crap around this kind of thing. On some of the ones that have burnt before, what I have done is I've checked then resistance from our power in from the coil out to the pin on the ECU, as I have come across a few where when they have gone short-circuited, they have melted the or burnt the trace inside the board, and in those ones what I had to do was in fact run a new wire out and sort of bypass that trace just out to the pin, as sandwiched inside the board there, the original copper trace would have got very hot and burnt itself up a little bit, and that then starts taking away your power. When you do have excess resistance, that will give you excess heat, and again, yeah, you can start sort of burning other bits and pieces, so that's going to be good. Now for general stuff the solder I was using in this one is regular 6040. There is a 6337, which is again a little bit fancier. A lot of people prefer that one. I'm using the 6040 because that's what I've got. I don't really have any issues with it, but the 6337 is kind of like the Gucci of solder compared to what I've got, which is fairly regular. Temperature settings on the iron, I have this at 370 Celsius, and that works out as about 690 Fahrenheit, and that does fine for me, or at least that's what my iron is telling me the temperature is. They might not be all that accurate, but you'll want a decent amount of heat so the solder does flow nicely, and then yeah, you should start getting these nice clean fillets around all of your joints. That's him cleaned up now. Just a bit of isopropyl alcohol and a rub with a toothbrush does the job just fine. So then we have to, you can see how clean that is now. We're going to stick back on our plastic clamp and then our metal spring holder. These are the same all the way around. All of these three plastic insulators, all of these clamps, they're all exactly the same. The legs that we've got on there means they can only go in one way, and once we fight him in, there we go. That's him now, ready to be put back together, and job done.